Okay, I hope everybody can hear me. My name is Emad Felemban. I am a professor in Al-Qura University that is placed in Mecca, Saudi Arabia. Uh, I apologize for not having for not or I, since I cannot enable my camera. Uh, for some reason, it didn't work for the last 2 days, but I really apologize for that. Today, we will talk about next generation crowd management issues and technology solutions. It's an experience, it's a journey that we have been doing for the last 7 or 8 years with my team. I will introduce myself uh, as we go along. So I will start with this picture. So my city, Mecca, has the Grand Mosque for all the Muslims. This is a typical image that you can see during the high season, where everybody prays toward the black cube, which is called Kaaba. It's a big crowd. We have 2 seasons that are very high. We have the Ramadan season where everybody is fasting. There is a praying going on, and there is the Hajj season where 2.5 million pilgrims come to the city to perform the annual season, the annual Hajj. My university actually lies across a highway from a place called Arafat. Arafat is a very plain area where 2.5 million gather all together uh, to perform the Hajj. It is the only place, by the way, the Hajj areas where all the pilgrims they gather at the same time. So it's a very big area. And obviously, my university and most of the researchers in the universities are concerned with this event organization, with the Hajj, since it is an um, okay. So what I was saying, that my university is just across a highway from Arafat. The Arafat Plain is the place where the 2.5 million pilgrims gather at the same time. It's a very it's a very wide and big area. So it is no, it's very obvious that my university and all the researchers over there, including myself and my team, we focus on different aspects of this event organization. From the logistic point of view, from the food industry, from the training, from crowd management, etc. So since I started in the university, that was in 2009, after I graduated with my PhD, I tried to introduce technology to this event. It was, and maybe until now, it lacks a lot of utilization of technology still. And the biggest obstacle that we have is data. We started to collect and we started to develop some apps and some tools to collect data. I will show you most of them in this presentation. So the data is a very challenging uh, issue. We don't have enough data, especially the data for mobility, for movement, where the people goes and how and when did they go. Since you cannot really gather this kind of information, or since you cannot comprehend this data from 2.5 million, it is very challenging, and we need to be creative and create tools that do not obstruct the mobility, do not actually overwhelm also the pilgrims or the visitors, and it is not also costly to the government. So we started to do some mobile apps just to know, and we downloaded them to some pilgrims who volunteered to help us to collect the behavior data. When do they go? How do they go? What do they do at certain places of the Hajj? We also started to do or to work on crowd simulation, where we introduced this concept to most the entities. Of course, there was the concept of crowd simulation, but we tried to make it as simple as possible, and we tried to help them understand the capability of crowd simulation and the applications for that. For example, this scenario we did for the authority that maintains the Grand Mosque. And we just introduced the idea of crowd simulation and how it would be helpful to make decisions on an organization of people making the circulation and around the Kaaba. In this, for example, a project we helped the Ministry of Hajj schedule the pilgrims to move from the camps to where they do the stones. Since there are very limited resources available, infrastructure resources, time scheduling is very important just to regulate the movement from one place to another. And this is just one example of this regulation and this time scheduling tools that we built. I will explain more on this. We did also, we converted this into a manual thing or a manual task into an online task, a real-time task where they can reschedule group of people if there is an emergency, or if they wanted to just change the timing, if the time is not suitable for them, to change it from one time zone to another time zone. Also, I had experience with command and control rooms. I get into most of the control rooms available for Hajj, or to control this organization, or the event. And we had a very good idea on how to develop these and make it easy, or to make it simple for decision makers to take decisions. Instead of, most of the control rooms right now are only broadcasting cameras, but we introduced the concept of adding more analytics and building the new generation of command and control rooms where it depends on data. It is data based control rooms. In 2020, during the COVID, my team and I, we have been working with the Ministry of Hajj to organize this very special pilgrimage. Only 1,000 were there, but it was in a very organized way. Because of the COVID restrictions, only 1,000 were allowed, and we had to introduce a lot of new concepts that we couldn't introduce during the normal pilgrimage. So I'm not. I think I missed. I think I introduced myself during the time when the connection were broken. So I am a professor in computer engineering department in Al-Qura. I graduated from Ohio State University in 2009. I joined Al-Qura as an assistant professor in 2010, and since then I have been involved in multiple projects, and I received multiple grants on how to develop technology for the Hajj and for the event. Lately, I have been involved in consultation project with different departments, including Ministry of Hajj. Is actually the ministry or the body where it takes the responsibility for organizing the event of pilgrimage. I had the chance to work also with an authority that contains the train, or that manage the train to move about 360,000 pilgrimage from different places. I also had the chance to work with the Grand Mosque Authority, where we introduced a lot of concept on how to manage the crowd during in the Grand Mosque. If you remember the first image. So now, for this talk, let me just introduce the challenge that we are facing every single year and during every event. So this is the different locations where the pilgrimage happens. If you can see on the right-hand side, we have Arafat, and then in the middle we have Muzdalifah, and in the left side we have Mina with the yellow overlay, and Mecca is in the down. This is the Mecca. This is part of Mecca City. Mecca City actually extends all the way to the left side. So pilgrimage or pilgrims, they move to Arafat on the day of 9th of the last month of the lunar system. And then they move after sunset from Arafat to Muzdalifah. And then after the dawn, on the next day, before or after dawn, they start moving in crowd from Muzdalifah to Mina. So most of the pilgrimage, they use buses to move, to do that. But around 600K of pilgrimage, they stay until dawn of the day of 10th, and they start to move all the way from Muzdalifah to Mina to throw the stones. So this is part of the rituals. We put a camera here on this highway. You can see it. So those two lines here are actually the walkaway lines coming. So Arafat is in the back. People are moving forward to the front of the screen, and we placed our camera on this highway. If you can see it in the lower of the image, we put it this way just to see and to capture how big was the crowd. You can see this is from after the sunset of the day of 9th, and this is how it looks like in the day on the, we call it the Eid day, on the morning. So you can see this vast number of people. This huge crowd is just waiting for the sunrise or a certain time after the sunrise, and they will start moving all the way to inside the third place of the Mashar, which is called Mina. And this is famous. To be honest, this is where they stay for 3 days to do some rituals over there. So they start. So this huge crowd from the right side, they will start moving inside this area called Mina. And if you notice, they will go through different streets. Those streets are not so wide. The maximum width would be 10, 15 meters. So the whole crowd will go and distribute in different areas. I will show you a couple of examples. So this is Mina on a different angle. You see the crowd coming from all the way from the back of the image, going through the different streets. If you can see uh, those white blocks, if you can see them, the squares are camps where people they stay and they spend the night and then wake up in the day after. But this crowd actually will go through all the streets, connecting the back of the image or back of Mina all the way to the front. If you see this huge crowd, they're moving, crossing those streets. They want to go and throw the stones at the other end of Mina. So this is a typical image or a typical scene that we can see in all the streets that you see here in the back picture, from around 7 a.m. all the way to 10 a.m. in the morning, and it is very dangerous. And it is very, if there is any issue, it might be very deadly. So this is one of the biggest challenge that we have, is actually how to manage the crowd in these 3 hours, or maybe also later, but this is the maximum, this is the peak hours of those crowds. Again, the numbers might be around 600 K. This is an estimate. We don't have enough. We don't have actual numbers, but I think this is a very good rough estimate. And most of the logistics and security forces and health departments, they are on their toes, just trying to help everybody reach their destinations safely without any problem. So this is an overlook on the whole Mina. If you can see, people are coming from the back here all the way through the different streets, and then they come to this massive building to throw the stones. This is a building where it has 5 floors, ground from the ground all the way to the fourth floor. It can hold up to 600,000 pilgrim per hour. But all the streets, the back streets connecting the camps to this building can only hold about 120K or 120,000 pilgrim per hour, which is actually why we needed scheduling in the first place when I told you about it. So that is a very challenging situation where we need a lot of effort to fix and help decision makers and help security forces to avoid any problems over there. So this is how it looks like once this massive crowd enters this building. It has four, if you can see, four main streams, and it also has a lot of minor streams from different places. But these are the four feed streams that are getting into the building. So you can see those crowd are actually walking almost about 6 kilometers in one shot. So once they reach here, they are tired. They are, they have a lot of different feelings, and they have an anxiety as well. They just want to finish, because once they do this ritual, they finished almost most of the rituals that is needed. So based on this experience, based on these challenges that we have, based on our past experience, we noticed that the lack of using the advanced technology is very apparent in the organization of Hajj, and even in the organization of any crowd management. Um, so we needed to use the new technology, the advanced new technology, the disruptive technology that we call it, the fourth industrial revolution technologies. AR, artificial or augmented reality, virtual reality, artificial intelligence, computer vision, big data analytics that we collected, modeling and simulation from different point of view that we will talk about, data visualization to help decision makers actually do and take decisions quickly with ease. So that was a big major uh, observation, and actually a big major goal for our research agenda that we had since 2 years ago. The second issue that we are also facing, and I think also it is applied to uh, any crowd management in every event, is actually critical knowledge. How to retain this critical knowledge? Since we are lucky to have the Hajj every year at the same time, so it will be a repeated experience, but still retaining the experience and the knowledge of all of these crowd managers who passed through the event actually is very important. Next year, we might have them this year. The next year, they're either retired or deceased, or they move to somewhere else. So how to train the new generation of crowd managers? How to get all of these experience and knowledge into a certain into a depository where we can always get back to uh, digitize it and turn it into training material or turn it into an experience. How to maintain this organizational memory? Because the Hajj or maybe any massive crowd event, actually it's a multi-organization effort. So we have multiple organizations that are working together to make this event successful. So these two goals that we had were actually we wrote a proposal for the Ministry of Education in Saudi, and we received the funding uh, for about 7.5 million for 3 years. We are still in the first year. We didn't actually receive the funding for the next two years, but we did a lot in the first year. Our vision was actually to change this typical command and control center, and this is what I have been saying in the beginning. We had very nice command and control centers, super massive screens, very interesting, but the usage of technology is very limited. We can do much better than this. We can use different technologies. crowd simulation, we can use prediction, we can use visual analytics or vision analytics to analyze the flows, to get the numbers out of those streams. We can feed them into a prediction algorithm where we can predict where and when some issues will happen. We can use crowd simulation to verify the solution to these, and we can draw a lot of visual analytic graphs and tools where we can help the decision makers in advance. So our goal was to change the typical command and control center into a data-driven command and control center, or what we called it, command and control center version 2.0. The second issue, or the second, for the second goal, we wanted to change the experience of training and education and educating the new trainee or new crowd managers using the new technology of gaming and virtual reality. So how to utilize the three most of the year, since this is an event for us, as I told you, an event for 7 or 6 years, for 7 or 6 days, how to utilize the remaining of the year for training and as real training as possible. So using game theory, or using the advanced gaming tools, using virtual reality tools. How can we make this training as real as possible? So we had this project called Hushood Amina. It's by the way in collaboration with Dr. Majid Sarvi in University of Melbourne. We put some 7 goals or 7 research threads that we are going to work on. Starting from the left, we wanted to work on technologies. The first 5 are actually the technologies that we needed to build the new generation command and control center. The last 2 with the white, with the light blue, are technologies that are used to maintain and to retain the critical knowledge and to deliver this knowledge to the new generation. So starting from computer vision, from the computer vision field, as you can, if you remember, I showed you this slide before, and we had about 4,000 cameras all over the place, all over the different places for the pilgrims, just to monitor how smooth is the mobility. So this is our first challenge: is how to digitize this visual data to mobility information, how to convert them. We have a feed of 4,000 cameras, how to convert them into mobility information. We needed at least the flow rates, and I think all of you appreciate how important is the flow rates in every crowd management project. So we needed to know the real-time resource utilization, how each street is utilized. We needed to know the flow rates. We needed to know the path and tracking of people. We needed to know also the density maps available for each infrastructure or for each street. We can use those in planning and real-time monitoring as well. So during the last 10 years, we have been working on different smaller projects and different smaller tools that we developed. For example, this tool, we put a camera on the Grand Mosque just to count the number of people crossing a virtual line, and we created a flow rate diagram. I know there is a lot of commercial tools available, but as far as I understand, or as far as I know, there is no commercial tool that is available for a wide area with a lot or with dense crowd. So we started to do this since 2010. We started to experimenting using different methodologies. Even before we utilized the AI, we used just simple image processing techniques to do the counting. This is another project where we put it in front of the Jamarat building that I also show you, just to do the counting algorithms. We placed the camera over there and to do different methodologies of counting. This is one also sample where we introduced abnormal behavior. If you notice the guy with the crossing the flow, everybody is going through the same flow, but this guy is crossing, making it 90-degree cross. So we identify it using just an overlay color. So this kind of technology or this kind of tools we wanted to build for decision makers, just to show them the capability of these new technologies. This is also another sample where we, for example, this is around the Kaaba. We showed here, if you see the cleaning crew is crossing by, so he created a little bit of a condensed area or a stoppage on the flow, and we created this overlay based on the real time status. This is another view of how to utilize also the visual assistance and how to add those visuals to assist decision makers that there is a problem here somewhere. So they can either reduce the congestion or reduce the density or stop actually feeding people into this area. This is another sample. Again, if you see the flow is getting into all red color. Of course, these are the threshold that we could do, and we can also. I'm really sorry for the noise. We can also utilize those assistance, visual assistance for them. This is actually tracking, so we could use tracking algorithms to do a lot of to calculate a lot of parameters. For example, how long does it take people to cross, let's say, a certain length, or where do they go in different places. Let's say this one is another tracking algorithm, or the same tracking algorithm on a different scene. This is some counting algorithms that we also use for still images. This is also tracking for a wide area. We just wanted to know the path that they select, that people select in a very open area, and this is very helpful in actually planning and estimation of density in different areas. This is another view also that we used. In this case, in this image, we draw the green or the moving people with the green lines and standing people with the red lines. So we pretty much know where do they go after they exiting from the Grand Mosque. If you see the Grand Mosque edge would be on the right side, and people are going into one line, and then they distribute it into different places. This might be obvious, but at least we have now a scientific way or a quantitative way to tell exactly where and how do they go. This is one sample of how to calculate density in a very quick manner. Also, it is very important to do that in a quick manner. This is also a movie about how to estimate the time it take for the tawaf area with different sizes uh, according to the time, according to the activity going on. So that is all about computer vision, and to be honest, it's a big field that requires a lot of effort. As I told you, we have more than 4,000 cameras easily, but the technology available, the commercial technology available from different vendors, even they're not capable of doing a lot of things. We might get some flow rates from different. We saw that from different big vendors available in the Hajj, actually in Mecca, but we still needs a lot of analytics to be drawn from there. So the area and the research for this area is actually, I think, is very wide open. The second thread that we focus on is the infrastructure digitization. Actually, it will end up to something called digital twinning, and this is very important in the planning phase because, uh, and especially for our project, we collected a lot of data from different places, including Google Maps, and we created something very digitized and very has a lot of depth of digitization. It contains more information. It contains a lot of digital data that we could use in the planning phase. So we started with the basic knowledge of the data. We started drawing things, the big blocks in our map, and then we started to add the infrastructure, the roads, the buildings, and we started adding, say, the road, the crowd infrastructure. And then we started to add more details into different places. Let's say how many pilgrims are living here, what are their nationalities, what are their behavior, how do they do certain activities. So we start to collect more information and more depth about not only the infrastructure, but also about the people living in the infrastructure. So in this case, we treated every single camp with a lot of data, let's say including the number of pilgrims that lives here, the office numbers, the gates, even the nationality, even the coordinates. We divided also each segment of the road into the multiple segments, or each road into multiple segments, and we can treat that as a digital input, as a digital entity. So, and even we built the capacity or estimated the capacity for that entity, for that segment. So at least we know exactly when once we deal in real life, we deal with that segment as a digital entity. So we know how many people are getting in, how many people are getting out, who are the people who are there, and then we can connect it also to the vision, the computer vision part, where each segment will contains a camera that is actually pointing that, or a camera, sorry, is connected to each segment, and we will know exactly that this camera is connected to this segment as in particular. At the end, we created a very big GIS layer that contains a lot of information, and we converted that into an interactive map where we could access all of this information using an interactive map, where that would be very easy to use. That would be very easy to use for decision makers. If you can see, we turn this, and it was very hard for them. We noticed that it's very hard to decision makers to work on GIS software, but we make it as very simple for them to do to work with maps on this platform. This is another function where we could see the difference between different years, what happens, what new development happens, what new changes happens, if those group of people from this certain nationality have moved to different places or no. So we could tell the difference in different years. At the end, we are actually planning to make a digital twin, an exact digital twin of the infrastructure, where we could actually, where we wanted to access every single uh, infrastructure as a digital data. That would be very helpful in the planning phase. It would be also very helpful in the digital, or actually in the training phase. I'm really sorry. These some efforts that we use to calculate to do some spatial computing, and this is actually a 3D scanning using lidar. Using that we use a drone to do that. So we have a 3D and the 360 degrees scan, as is scan of Mina infrastructure. Again, the idea, we wanted not only to digitize the infrastructure, but we also wanted to create a digital twin that we could use again for planning on how the pilgrims are moving, and also for training as well. If we want to train new generation of crowd managers about the infrastructure, because it is a big part of the event organization. Sorry, I think I'm going backward. The third what we did was the spatial computing. Once we build that infrastructure, once we build all of this digitized information, we start to do a lot of computational and analytics to work. Let's say, would those guys, for example, would some pilgrims from a certain nationality, would it be better for them if we move them to this location because they will be reaching uh, or they're doing their rituals at this time or no? So we start to do a lot of permutations and a lot of computation on what would be the best way to locate those people. If you can see those if you notice the rectangles, the small rectangles are considered as camps. Each camp contains about 2,000 to 2,000 to 3,000 people under one serving entity, under one management. So we could actually replace each one with the other place if each one has a preference. So once we collected all of the preference data from the pilgrims, we could see if we could do the allocation of each entity at the same time. So also we developed some routing algorithms, since we cannot utilize, let's say, Google Maps to find ways or to navigate. A lot of restrictions, a lot of changing routes are available during those special days. So we had to build our own routing algorithm to guide the people, to guide the pilgrims on how to go from their source to destination. Uh, the last, or actually the fourth thread, is about modeling and simulation, and I think you all are aware of this. We used a lot of tools available, including mass motion, Pedestrian, who were developed by Dr. Majid. Enologic was a very good. Also, they had a very good simulation tool. We used also SimWalk at once. So we used a lot of simulation tools that are available to create or uh, to mimic real-time scenarios. So this is just a sample of one street that we work in the simulation of all of that to simulate the mobility of people across that street. This is another, or this is actually the same street all together from the beginning to the end. And then so this is actually the whole street the whole street simulated. I'm not sure if the video is working or no. Okay. And then these are actually some simulation tools that we did for the train stations inside the Mashar. So we have 9 stations. The train system can hold up to 360,000 people. It will do the mobility or this mobility within 6 hours, or actually no, within I think about 12 hours, going back and forth from different locations for the Hajj. These are some simulations for the Grand Mosque on different layers. This is again a sample simulation for the train station. We just wanted to know if our scheduling algorithm for those train stations is going well, and it goes along with the schedule of the train itself. These are some samples that we created just to train my students on how to utilize crowd simulation. So we just wanted to introduce crowd management to them by running just a dummy scenario. So it could be a very useful way to do the training. Lastly, the dashboard visualization at the end, after we did all of these data collection and we converted the images into data, and we did some analytics, we did some spatial computing. I think it's the time now to turn our regular screen or monitors into a data-driven dashboards, and I think I have mentioned that in the beginning. That is one of our major goals in this project, is how to create a concept of data-driven dashboards. So we started doing some KPIs and analysis. we start to develop some dashboards that we implemented in collaboration with Ministry of Hajj and implemented in the season itself. This is, for example, a dashboard, a very simple dashboard, but it's very informative at the same time. If you can see the numbers in the top, this is actually how many people are still didn't do that ritual, and how many people are they left out, and how many people they are on the way, and how many people they reach and they finished. So people or decision makers in during the event, they are looking at this kind of information. They only just need numbers so they can at least uh, reallocate their personnel, anticipate if there is any problems, and actually for monitoring as well. Uh, they actually also go and look and see who left and who didn't do the ritual according to the timetable, so they can go and account them responsible for any mistakes. So this kind of this kind of simple dashboards is very informative for the decision makers, and it's very simple at the same time. They can get the numbers quickly, and they can get the data or the information that they need quickly and easy. Again, this is, we mentioned this before, but this is also a kind of simple dashboard where we combined the geography, or actually GIS data, with some dashboards on the right, with numbers and graphs. So that also is very interesting and very easy way to display information from multiple sources. Um, so this is one of the dashboards that is live during the Hajj. This is during 1441. If you notice, it's very plain. Only 1,000 people were doing that Hajj, but we did that implemented. We did those KPIs and implemented them during that. We introduced them during that season. I think I have about 10 minutes, so I'll go a little bit quickly. So knowledge management is a big thing again. Uh, so we wanted, as I told you, to retain the knowledge. So we started to develop some tools to evaluate this experience from the crowd managers. We wanted to capture their knowledge and put it and digitize it somehow. To be honest, until now, there is no clear rule, or there is no clear path for us to do that, but we are trying our best to make an ontology, or to make a taxonomy that gather everything together. So we started to do some frameworks. We started to do some tools to capture. We invited a couple of crowd managers, and we asked them very simple questions about what is their opinion. For example, these are four different questions that we add in our test. The one starting from the left, we asked them how many people do you see in the picture. We wanted to have his answer in about 7 seconds. So we gave them a question, we give them multiple options, and we give them a very restricted time. So we just wanted to measure how responsive he is, and how rough, how rough estimate, how accurate his rough estimate is. And we did it with multiple and different questions. Let's say the number of people in the left, and then we wanted just to know, is there any congestion or no in the second one. And then, for example, can you identify the different flows here and there. And in the last one, do you think that this is like what is the kind of behavior is this one. So we have multiple questions, and if we couldn't find a material suitable for that question, we created this using a simulation, as you can see here. And we just wanted to measure this. We still didn't implement this test. We wanted to invite at least around 50 people or 50 crowd managers to get their data and analyze, and then move forward with different ideas. Lastly, serious games, as I maybe also mentioned in the beginning, it is very famous. It is used in different very critical training, let's say firefighting or airplanes, as you know. So we wanted to create this tool. We wanted to utilize this tool actually for crowd managers. And I think I have been looking for this kind of this tool, but unfortunately I couldn't, to be honest. So we started to think on and put ideas on how to think this. So we started to build the digital twin of the whole MENA. We started to replicate things into a digital. Of course, it will all depends on our previous effort. We have, remember that we have a fully digitized infrastructure and GIS layers. So that was very helpful in this case. We only build the 3D models, and we start to create scenarios using VR and engines. And we are still in the very early stage of this development, but we wanted to build scenarios as simple as possible so we can move forward in this project. Thank you very much for your time, and I hope this give you some inspiration or shed some light on what are the activities that are going on for the crowd management, and especially for crowd management in Hajj. Thank you very much.